Today we are going to learn about mastering Keras Functional API for complex models. We will explore designing complex deep learning models using the Keras Functional API, crucial for building flexible and scalable neural network architectures.
Welcome to this tutorial on mastering the Keras Functional API for complex models. In the world of deep learning, the Keras Functional API provides a powerful way to define and build models that require complex architectures, such as multi-input or multi-output models, or models that share layers. Unlike the Keras Sequential API, which is limited to a linear stack of layers, the Functional API offers the flexibility needed to design more advanced neural network architectures. This makes it an invaluable tool for AI practitioners and researchers who need to construct scalable and efficient models. Let's dive into the essentials of the Functional API and how it differs from the Sequential API, setting the stage for the complex models we'll be building in this session. To get started with the Keras Functional API, let's build a simple model. We'll begin by defining our input layer using the input class, specifying the shape of the input data. Next, we'll create a dense layer and connect it to the input. This is done through the Functional API's ability to use layers as functions, allowing you to pass the input layer directly to the dense layer. This flexibility is one of the key advantages of the Functional API. You can continue to add more layers, connecting them as needed until you define the output layer. Once the model architecture is complete, you'll compile the model by specifying the optimizer, loss function, and metrics. This process is similar to compiling a sequential model, but with the added benefit of having a more flexible and customizable architecture. Finally, you can train the model using your training data. This simple example demonstrates the basic steps in creating a model with the Functional API, showcasing its advantages in terms of flexibility and scalability.
One of the standout features of the Keras Functional API is its ability to handle models with multiple inputs and outputs. This is particularly useful in complex scenarios, such as when you're dealing with multiple data sources or need to make predictions on several outputs simultaneously. To create a model with multiple inputs, define each input using the input class, specifying the appropriate shape for each dataset. Once you have your inputs, you can process them through separate layers or branch them into different pathways within your model. To handle multiple outputs, define separate output layers for each task. These layers can be connected to the same or different paths within the model, depending on your specific requirements. This approach allows you to create models that can learn and make predictions on multiple tasks concurrently, which is an essential capability for many real-world applications. By understanding and utilizing these features of the Functional API, you can design models that are not only more capable but also more aligned with the complex needs of various AI projects.
Shared layers are an elegant solution for improving the efficiency and performance of your models. By reusing the same layer instance across different parts of your model, you can significantly reduce the number of parameters, leading to smaller model sizes and faster training times. To implement shared layers using the Keras Functional API, define a layer once and apply it to multiple inputs or parts of your model. This is particularly useful in scenarios where the same feature extraction or transformation is needed for different inputs or branches in your model. For example, in a model that processes text and images, you might share a dense layer for feature extraction across both data types. Sharing layers not only optimizes the use of resources but also ensures consistency in how different parts of your model process data. This technique is widely used in models that require parameter efficiency, such as Siamese networks or multitask learning models. By leveraging shared layers, you can create more efficient and scalable models without sacrificing performance. Designing complex network topologies is where the Keras Functional API truly shines. Unlike the Sequential API, which limits you to simple, linear models, the Functional API allows you to create intricate architectures with nonlinear connections between layers. This capability is crucial for modeling more complex relationships and interactions in your data. To design a complex network topology, start by defining the basic structure of your model, including the input and output layers. Then, use the flexibility of the Functional API to create branches, merge layers, and establish custom connections between different parts of your model. This might involve creating parallel pathways for different types of data processing or implementing skip connections to improve the flow of information. Complex topologies are often used in state-of-the-art models, such as ResNets and dense nets, which rely on sophisticated architectures to achieve high performance. By mastering the design of complex network topologies, you can build models that are more powerful and better suited to tackle challenging problems in AI.
The Keras Functional API offers the ability to integrate custom layers and functions within your models, extending their capabilities beyond the built-in options. This is particularly useful when you need to implement specialized operations or transformations that are not available in standard layers. To create a custom layer, subclass the layer class and define the necessary computations within the call method. You can also create custom functions to encapsulate specific operations, which can then be used as layers within your model. This level of customization allows you to tailor your models to meet the unique needs of your projects, whether it's applying a novel activation function or implementing a specialized form of regularization. By integrating custom layers and functions, you can push the boundaries of what your models can achieve, making them more versatile and effective for a wide range of applications. Examples of custom layers might include attention mechanisms, specialized convolutional layers, or unique pooling strategies that enhance the learning capabilities of your models. The Keras Functional API offers several advantages over the Sequential API, making it the preferred choice for building complex models. One of the primary benefits is its flexibility, allowing you to design intricate architectures with nonlinear connections between layers. This is essential for creating advanced models that can capture complex patterns and relationships in data. The Functional API also supports models with multiple inputs and outputs, a feature not possible with the Sequential API. This capability is crucial for applications in multitask learning, where a single model needs to make predictions on several tasks simultaneously. Additionally, the Functional API allows for the implementation of shared layers, leading to more efficient models with fewer parameters. This enhances the scalability of your models, making them suitable for large-scale applications. Overall, the Keras Functional API provides the tools you need to build sophisticated and powerful models that can tackle a wide range of challenges in AI and machine learning.
To make the most of the Keras Functional API, it's important to follow best practices and be aware of common pitfalls. When designing your models, start with a clear understanding of the problem you're solving and the data you're working with. This will guide your architecture decisions and ensure that your model is well suited to the task at hand. To avoid overfitting, implement regularization techniques such as dropout and weight decay, and consider data augmentation to increase the diversity of your training data. Efficient training strategies, such as using learning rate schedules and early stopping, can help you achieve better performance and avoid wasting computational resources. One common mistake to watch out for is neglecting to properly define input and output shapes, which can lead to errors during model compilation. Additionally, ensure that your model's architecture is neither too simple nor too complex for the problem, as both can lead to suboptimal performance. By adhering to these best practices and being mindful of potential pitfalls, you can optimize your models for success.
In conclusion, mastering the Keras Functional API opens up a world of possibilities for building complex and powerful deep learning models. We've covered the essentials of defining models with a functional API, explored how to handle multiple inputs and outputs, implemented shared and custom layers, and discussed the benefits of this approach over the Sequential API. As you continue your journey in deep learning, remember to experiment with different architectures and push the boundaries of what's possible. The skills you've learned today will serve as a strong foundation for tackling a wide range of AI challenges. We encourage you to apply these concepts to your own projects and explore the vast potential of the Keras Functional API. Thank you for joining us, and happy modeling!